The information and recommendations outlined in this presentation are not intended as a substitute for personal medical advice. The presentation proposes certain theoretical methods of nutrition not necessarily mainstream. It is left to the discretion and it is the sole responsibility of the user of this information to determine if procedures and recommendations described are appropriate for a patient. Neither the authors nor the sponsors of this CD can be held responsible for the information or any inadvertent errors or omissions. This information should not be construed as a claim or representation that any procedure or product mentioned constitutes a specific cure. Statements and health claims regarding products in this CD series have not been evaluated by the FDA. Products mentioned in this presentation are not intended to diagnose, treat, cure, or prevent disease.
Okay, so thank you guys for coming in. I know it's not easy to come out to these things all the time. Just to add something to that, the blood chemistry course that we're going to do called Mastering Blood Chemistry, if you guys have been to our previous blood chemistry courses, it does not matter, okay? Because the amount of information that we've done to upgrade it is, I mean, my goal was to cerebrally violate everyone who thought they'd mastered blood chemistry in this course, So there's a lot of new information. It's to the much greater level than we've ever taught before. And if you're interested in going, May and June is when we're doing it. I'm only teaching it May and June, and then I'm never teaching it again. And then other people will teach it. So if you guys, some people like to learn from me. If you guys want to learn from me, that's the 2 dates I have, okay? Okay, so you guys, today's topic is a really important topic, the inflammatory and autoimmune signaling systems. And one of the things that you really have to consider is when we look at the population that we're all seeing, it's very clear that we're seeing really sick chronic people. As time goes on, we're only going to see more of them, right? You probably have all seen in your practice, you're seeing more and more chronic people and much less of the acute people, and it's going to be an ongoing trend. And you're also seeing these types of disorders with people at a younger age, right? We look at the rates of autism and childhood developmental disorders and autoimmunity in children, it's really getting really scary. So one of the things that we know is we have this growing population of chronic disease people, and they're not necessarily, let's say, disease people. They're just chronically ill people that don't really fit into a label of a disease yet. So they have headaches, they have migraines, they have abnormal cycles, they have infertility, they have pain, their body hurts, they can't sleep well, they're tired all the time. That doesn't really still fit the definition of a disease, and that's pretty common for us to see. Now, practitioners of the future will be the ones that can address those, and the ones who don't know how to address those will probably just fade out and be kind of obsolete. Does that make sense? As the economy gets strained, we saw a lot of people lose their practices. The ones that weren't serving the community, serving the population well, no longer exist, okay? So as time goes on, one of the demands that's faced upon us as healthcare practitioners, how do we work with people that are chronic? Does it make sense? The ones that don't have a disease yet, that are in the healthcare system, may be taking multiple medications for each of their symptoms, right? They might be taking a sleep medication or something else, to get their system going. But those are the people that are probably going to be drawn to us. Those are the people that don't really have much answers given to them in the conventional pharmaceutical single symptom, single drug model, and are looking for people like us, okay? Now, when you look at the chronic-based population, there's a couple things we have to really look at. Not everyone in the natural medicine world is going to have a success with this group, okay? And one of the problems is we have too much of a philosophical-based nutritional model. Do you guys know what I mean by that? We have too much inefficiency when it comes to someone who's chronic, meaning this. If you have a person that comes into your office and they have 10 different complaints, headaches, can't sleep, body hurts, infertility, depression, brain fog, the whole list of stuff, right? If you go in there and try to treat them for every single symptom, it's pretty inefficient. Does that make sense? You can't go like, well, for your sleep, we'll give you melatonin, and for your abnormal cycles, we'll give you black cohosh, and then for this, we'll give you that, and blah, blah, blah. You guys understand? It's just inefficient type of care. And that's kind of how people are taught to look at natural medicine. If you guys look at any herbology book, how is it taught? The use of herbs are taught by symptoms. This symptom, you use that. The symptom, you use that. The symptom, you use that. If you look at textbooks written on natural medicine, it's become really bad because it's really based on what? Diagnose it, And here's your natural protocol instead of a pharmaceutical protocol. And then diagnose it, and then it's not really mechanistic based. Do you guys understand? Now, we know that when we see a person that has multiple types of symptoms, that we need to have an effect that's hormetic, and we need to have an impact clinically that addresses vicious cycles. Do you guys understand that? Because that is the heart of the most efficient way that I can share with you of how to look at chronic ill people. Okay, so let me kind of give you an example. Let's say you get someone that comes into your office and they have headaches, they have infertility, their energy crashes in the afternoon, they can't sleep through the night. Does that make sense? You can give them a bunch of infertility herbs, you can give them a bunch of sleep aid herbs, you give them like valerian and melatonin, you can give them, all this stuff. But maybe the underlying mechanism of all that is a blood sugar disorder. Maybe they're just hypoglycemic. Maybe their blood sugar is unstable. So instead of giving them 20 different things, you get their blood sugar stable. Now they can sleep through the night. Now they have energy throughout the day. Now they don't have headaches. And it was one single intervention you did that impacts on multiple systems. Does that make sense? Okay, so that is the concept of getting a hormetic effect. So hormetic is defined as a single agent that has impacts in multiple systems. A single agent that has impacts in multiple systems. When it comes to chronic illnesses, clinicians that know how to get a hormetic effect are going to have the greatest efficiency seeing a person that comes in with multiple chief complaints. Do you guys know what I mean by that, right? They're not going to do a single supplement for every symptom because that's inefficient. They're going to look at the big picture, understand physiology, apply the least amount of interventions to have the greatest impact. You guys all with me? Okay, so the goal of, when we look at the goal of efficiency in chronic health management is how do you get a hormetic effect? And the other major issue with clinical practice are vicious cycles. For example, dysglycemia is a vicious cycle. Blood sugar drops, then they have to eat sugar, and then they have another insulin surge, and then they go back into this vicious cycle all day. Things like intestinal permeability are vicious cycles. They eat something, they get inflamed gut. No matter what they eat, they get inflamed guts. It keeps promoting that leaky gut. So that's another vicious cycle. So when you look at the spectrum of these things, you go, well, how many mechanisms do I see? How do I impact all these mechanisms with the single application that has the most impact, which is a hormetic effect? And am I addressing vicious cycles? Do you guys understand? And the way we do that is just basically good old basic human physiology, not the theoretical model. You guys understand? We're not going to go, every autoimmune disease patient has parasites. Every autoimmune disease patient has metals. We're not going to do stupid, silly, overestimated types of concepts because you can't make statements like that because everyone is unique and different. Does that make sense? So we don't have a philosophical-based model of nutrition, meaning every condition has the same treatment. It's all different. You guys understand? So when we talk about the application, how we go into it, we're going to get into chronic inflammation today. We're going to get into autoimmune pathways, autoimmune signaling pathways today, right? We're not going to simplify autoimmunity to going, they all have parasites, they all have environmental issues, because it's not that simple. There's more to it than that. So one of the things we want to really focus on today is the inflammatory signaling system. And when you guys look at the inflammatory signal system, we know we have lots of different inflammatory mediators, right? We have inflammatory cytokines, we have chemokines, we have things like substance P, we have things like chemokines, right? We have a whole bunch of different types of compounds that are inflammatory. But when you look at that list of inflammatory compounds and you keep going down, it all starts with nuclear factor kappa beta expression. And that's what we're going to get into. Okay? So as an attempt to try to get to a hormetic effect, at an attempt to try to get to the mechanisms that have the most effect in dampening vicious cycle pathways and those that are chronic, we know that when we look at the inflammatory cascade pathway, we have this signaling compound called nuclear factor kappa beta. It turns on the inflammatory expression, and here's the worst thing. It has its own amplifying loop, so it feeds itself. There's a feed-forward cycle. Now, the thing that we want to really question, the thing we want to clinically accomplish, because you guys, ultimately, you have to have something clinically to take away, right? What we want to clinically accomplish is what's going on when we see the person who's eating perfectly well, has a great diet, is not eating hypoallergenic foods, and still has severe gut inflammation. What's going on with the person who is eating well and exercising, and they still have significant insulin resistance? Do you guys know what I mean? Those are people that are more difficult, right, to deal with. There's nothing weird about them. They have mechanisms that are physiological, okay? But most people go, oh, well, you're so complex, you're so weird. They're not. They just have a mechanism that's not being appreciated in their clinical workup. Now, it's pretty obvious if we see someone who's got insulin resistance and inflammatory gut issues, if they're eating Kentucky Fried Chicken every day and McDonald's every day, it's pretty straightforward why they're getting it, right? But the more realistic thing that we're seeing now is the person who is doing everything right, And despite that, still has a whole list of chronic inflammatory-based symptoms. Does that make sense? Okay. So these are the questions we want to answer today. Welcome to the party. Are there associations between inflammatory mechanisms and autoimmune development? And you guys, there absolutely is. Now here's the thing we're going to get into. We're going to get into this nuclear factor kappa beta expression. This is the key thing we're going to focus on today. And chronic nuclear factor kappa beta expression in the conventional literature has been associated with increasing risk for autoimmunity, increasing risk for also cancer, malignancy, right, and severe chronic inflammatory debilitating diseases. So this is an area that we're going to see signs of clinically before they progress into those things, or they may already be there. How do these cases present? So guys, when you guys see a person that comes in that has severe inflammatory gut, and they're taking tons of GI support and probiotics and glutamine, all these things for leaky guts, and they're left eating like salmon and celery and a rice cake, okay, what's going on? What else are you going to cut out? You're going to cut out their salmon now? You know, you're going to give them more of a, you're going to give them different probiotic, like it's better. You're going to pull out some other special glutamine from who knows where, you know, it's magical. It's not that. There's other mechanisms that are involved in those cases. Does that make sense? And that's really what we want to eventually get into. So those are the clinical things we want to address. And then, you know, does your family or your clients have any of these mechanisms? 100% absolutely. We all have some degree of pre-existing NF-kappa beta inflammation. You want to be able to recognize those things, and then the application to them. So let's go into the concept here. This is where you want to go. NF-kappa beta signaling, where it all starts. So we're talking about the inflammatory cascade, okay? Now, you guys all know, if you do a literature search, every chronic disease is really related to inflammation, right? If you look at mechanisms for cardiovascular disease, there's an inflammatory link. Neurodegeneration, inflammatory link, right? Autoimmunity, inflammatory link. It doesn't really matter what you look at. They're all linked to these chronic conditions are really based on a mechanism of inflammation. Once again, when you look at the inflammatory biochemical cascade, right, you have all these different inflammatory chemical compounds, but it all starts with nuclear factor kappa beta. So when we try to do an intervention, we want to go, how do we hit nuclear factor kappa beta most efficiently to have the greatest effect, hormetic effect, as we look at chronic inflammatory mechanisms, right? Okay, someone has chronic inflammation. Their inflammation could be in their brain. They have brain fog. They have depression, decreases nerve conductance. Their inflammation could be in their gut. They have bloating. They have leaky guts. They have dysbiosis, right? Their inflammation could be in their joints. They have joint pain all the time. You guys understand? So when the body's systemically inflamed, they're going to come in with a vast array of symptoms, right? And those are the things we want to do. We don't want to treat each symptom. We want to get to the underlying mechanism. So let's review NF-kappa beta. So NF-kappa beta is a protein complex that controls the transcription of DNA. It is found in all cell types. It is involved in cellular responses to stimuli such as stress, cytokines, free radicals, and antigens. Nuclear factor kappa beta controls the expression of genes encoding pro-inflammatory cytokines, chemokines, and adhesion molecules, inducible growth enzymes, COX enzymes, INOS, and growth factors. And that's the key point. A couple things here, okay? First of all, when you look at this, let me go back. NF-kappa beta is what turns our genes into an inflammatory cascade. Do you guys understand how profound that is? We all have an existing genotype we're born with, the genes we have. Environment, diet, lifestyle activate those genes. We either express into an inflammatory state or phenotype, or we don't, right? Some of our patients that are really chronic already express into severe inflammatory response. So if there's a DNA chronic expression of that, we know that there's a nuclear factor kappa beta type of response. You guys understand? So we want to look at mechanisms to dampen this type of activity. All the things that you look at that are inflammatory markers, whether you're looking at prostaglandins or nitric oxide or growth factors or adhesion molecules or other types of things, usually get triggered by the initial expression of NF-kappa beta. Do you guys understand? So when we're trying to get down to doing the most amount with the least amount of treatment, this is one of the key areas, signaling pathways we want to hit. And then, as we said earlier, chronically activated NF-kappa beta has been linked to cancer, inflammatory conditions, and autoimmune diseases. When you guys are looking at this diagram here, this substance right over here is nuclear factor kappa beta. So right here is nuclear factor kappa beta. And if you guys see on top of that, there's inhibitory kappa beta. You guys see that? IKBA? That's inhibitory kappa beta. And that inhibitory kappa beta pathway is there, and it suppresses its expression. Okay? So you have on the cell surface, you have this nuclear factor kappa beta protein, but on top of it is this inhibitory kappa beta inhibitory signal or a protein on top of it. And then what happens is on the cell surface you have this receptor. And there are certain things that turn on nuclear factor kappa beta. Those are oxidative stress, right? Inflammatory cytokines, immunological activity that releases cytokines. Any of those, perfect. Any of those types of things then turn on the cell's receptor that then produces IKK, which then takes off this inhibitory kappa beta. You guys see that? Let me show you this. So here's the receptor. All the things you guys have known to be linked to inflammation are what turn on the receptor. Okay? So again, oxidative stress, free radicals, inflammation, environmental toxins, those are all the things that we know is creating inflammation. The way those things create inflammation is they activate the cell surface receptor. The cell surface receptor produces IKK that goes to the nuclear factor kappa beta substance and then removes this protein. There's a heterodimerization phosphorylation removal of this, and then you see nuclear factor kappa beta as these two proteins here. You guys all see that? That is then small enough to go inside the nucleus of the cell, hence the name nuclear factor kappa beta, and it causes the activation of transcription to DNA to have a messenger RNA proteomic response to then create inflammatory proteins, inflammatory consequences. You guys all see that? Yeah. Okay. So we have this NF-kappa beta usually inhibited until something turns it on. Once it turns it on, the gene's then expressed into an inflammatory state. Everybody good with that? I'll show you some other slides in a second. Here's the scary thing about this. This has its own feed-forward amplifying loop. So once it's activated, it can continue to be activated even though the trigger is no longer there. You guys see the person who's got the leaky gut? They don't have the antigen anymore. They don't have the dietary food protein anymore, but they still have a gut on fire. You guys understand? That's an amplified NF-kappa beta loop. So those are the things you want to be able to pick up on, okay? And there are a lot of chronic people that have this. Some of these people develop what are called plasticity in this. In the literature, there's two types of explain NF-kappa beta loops. One's called NF-kappa beta loop plasticity. It's associated with neurodegeneration in the brain. These people have chronic inflammatory responses, and the brain just basically gets chewed up and degenerated away, associated with pretty much all the major inflammatory neurological diseases. And then outside of the brain, they have this so-called, what they call feed-forward amplifying loop. What this means is when this pathway gets chronically expressed and activated, even though the trigger is no longer there, there's an ongoing state of inflammation. Do you guys understand it? Someone can have like an environmental exposure 10 years ago, really turn on this NF-kappa beta pathway, it feeds itself forward and then doesn't shut off, even though they're not exposed to the environmental trigger anymore. Does that make sense? Okay. Now, when you guys are looking at this diagram, here's another illustration of it. Here's the activating signal. Here's the cell membrane, and then you can see the cell membrane. You can see nuclear factor kappa beta here. Something activates this. Again, environmental toxin, free radical, inflammatory cytokine. That then causes the inhibitory kappa beta to come off. The nuclear factor kappa beta can now enter the nucleus of the cell and then cause gene expression and then create inflammatory proteins, inflammatory consequences, okay? So this is the fundamental basics of this. Now, when you guys are looking at this nuclear factor kappa beta pathway, it's actually very important for us. And one of the reasons it's really important for us is because that's how we fight infections. So we have to have some degree of this because we have to have an inflammatory consequence to destroy bacteria, destroy virus, right? But it's the chronic, constant activation of this that then has been now linked to autoimmune diseases, chronic inflammatory diseases, right? Cancer and things like that. So this thing has to have some degree of activation so you can fight infections, but it can't become overzealous and it can't develop this plastic amplifying loop that doesn't shut down. That's when you start to get chronic illness, right? Okay. Now, I listed for you guys several papers throughout the presentation. I won't go through every single paper I put in your notes, but you guys have them. I'll go over the key ones for you. Here's a New England Journal of Medicine paper, and it goes into a review of all the major triggers for the NF-kappa beta pathway. And you guys see there's cytokines, protein kinase C, oxidants, meaning free radicals, viruses, immune stimuli, different types of antigens, things like lipopolysaccharides, pro-inflammatory cytokines, chemokines, inflammatory enzymes, adhesion molecules. So there's a whole list of stuff. Now, basically, this is a list of what we all know can trigger an inflammatory consequence. Okay? Now, here's the model that we're all usually taught. You have something trigger inflammation, you have an inflammatory response. If that thing is removed, then you're cool. Okay, that's not what happens. You have something that triggers an inflammatory cascade. That inflammatory cascade turns on NF-kappa beta. NF-kappa beta has the potential to feed forward itself, and if the stimulus is aggressive enough, Even though the antigen may be gone, it's still there and it's still causing a consequence of chronic inflammation, even though it's not there. Does that make sense? Meaning you guys might see someone who's got a gut, really bad gut, you may look for GI pathogens and parasites and all that stuff, bacterial overgrowth, it's just not there. You see? And by the way, this is one of the main consequences of chronic intestinal permeability. It doesn't have to be there anymore. Okay, the trigger doesn't have to be there anymore. Now, if it's still there, that's going to be an issue, but we're going to deal with cases that are beyond that. Now, what you see in this diagram is a 2011 paper. They just go into the main mechanisms that cause NF-kappa beta activation. Stress, and you guys, this is psycho-emotional stress too. Psycho-emotional stress releases interleukin-6. Interleukin-6 activates NF-kappa beta. So when you have an emotional response, you get this NF-kappa beta activated response. One paper that was published a few years ago found a fight with your spouse, domestic spouse fight, raises IL-6 levels for 3 full days, which is then turning on NF-kappa beta. Now, if we see someone who's got an inflammatory bowel disease or autoimmunity, we see that, right? They get in a fight with someone, they have an emotional episode, their autoimmune disease totally flares up. That's a IL-6 driven pathway. Now, here's the thing. Every single one of us has some degree of inflammation, right? Every single one of us has some degree of development of our NF-kappa beta inflammatory gene-expressed pathway. Those that are close to the edge may have severe consequences with trivial things, right? One person may be intolerant. They have 5 people intolerant to dairy. One person eats dairy, they don't really notice much. Another person eats dairy, they get severely bloated, assuming they're all intolerant to dairy. One person eats dairy and they're in bed for like 3 weeks. You guys understand? There's a different amplified loop that's there. It's not just the antigen that's doing there, it's their pre-existing plastic change with these inflammatory systems. Now, they go on to show that in this paper that these are all the things: stress, diet, chemotherapy, infection, obesity, we'll talk about these two, addiction. These things can all potentially turn on NF-kappa beta. And then NF-kappa beta, which in turn releases these cytokines, and these cytokines, guess what they do? They further turn on NF-kappa beta. I'll show you a diagram about this in a second. And then these things have been linked in the literature. This was a review paper to things like cachexia, anorexia, muscle wasting, anxiety, cognitive impairment, fatigue, depression, sleep disorders, neuropathic pain, delirium, right? So here's a question for you. Have you guys ever seen a patient come in that has fatigue, depression, cognitive impairment, and can't sleep well? Yeah? Of course you have, right? So let's treat every single one of those. No, that's inefficient care. Does that make sense? Let's diagnose each one, pull up the naturopathic book, look at it. Let's look at each symptom, pull out their herbology book, pick each single herb, give them a whole bag of stuff, give them a rotator cuff tear, and then, assume why, then be puzzled why they're not getting better, But you guys, this is what happens. You guys all see patients coming into your office, right? You see the files, you see what's been done, you look at the extent of workup, but there's nothing there, Many philosophical treatments unrelated to physiology, right? One practitioner gets better doing something, now every one of their patients have it, It's that kind of stuff. Okay. Now, when you guys look at the NF-kappa beta pathway, signaling pathway, here's what happens. What you see in this diagram, and we'll show you, there's a bunch of papers that go into most of these things, is the other types of chemical messengers that get activated when you have NF-kappa beta activation. For example, lactate gets activated. If you have too much lactate, what do you get? You get muscle aches, you get muscle pains, you get things like fibromyalgia. Things like leptin get increased in activity. If you get too much leptin, you get leptin resistance. What do you get? You're always hungry. You can't control your appetite. You get insulin resistance developed from these things. You get things that destroy blood vessels. So there's a whole cascade of events that take place from this. Do you guys understand? Okay. So once again, we see a whole list of reactions, whole list of responses. We know there's an inflammatory component to their system. Now, let me show you a couple papers. This was one related to atherosclerosis. This is a 2004 paper. And they go on to say, our data directly analyze the functional role of NF-kappa beta in human atherosclerotic tissue. Our study is a step forward towards specific identification of components of NF-kappa beta pathway involved in disease, which possibly could guide the future development of clinically useful inhibitors. Guys, the world of pharmacology is working very, very hard to figure out how to shut down NF-kappa beta pathway without causing total immune suppression. There are NF-kappa beta pathway drugs that are used, but for like cancer and for severe autoimmune disease, the problem with them is when people take them, they can get a common cold and die from it because it massively suppresses their immune system. You guys understand? Okay. Now, in the literature, there's even more information published about natural compounds that have an effect here, which is what we're going to get into. So there's things that we can clinically do, and I'll show you guys the studies with them, and they've been used for autoimmune diseases and all types of things in the literature for effects. The two main ones are curcumin and turmeric. curcumin and resveratrol. Curcumin turmeric being the same compound, resveratrol and, curcumin turmeric compounds. Now, here's another paper. They go into this. Since NF-kappa beta represents an important and very attractive therapeutic target for drugs to treat many inflammatory diseases, including arthritis, asthma, and the autoimmune diseases, most attention has been paid in the last decade to the identification of compounds that selectively interferes with this pathway. Do you guys see why they're so concerned about making an effective drug for this? Because it can be used for what? Used for everything. Okay? Now, they're nowhere close to doing that right now, but this is there's some serious investment of time, energy, and money to do. They want to be able to do this. They found resveratrol. If you guys do a literature review, resveratrol has the best ability to do that. Now they're developing a synthetically derived resveratrol to label as a drug, and when they do that, they'll probably take off resveratrol off the market. I think it's a matter of time. Yeah, that's probably what's going to happen because the evidence is so strong with that compound. Okay. Now, you guys, there's different antioxidants, there's different ones, but the ones that have the most evidence for shutting off NF-kappa beta is curcumin and resveratrol. This is why Apex really took them about 2 years. They formulated the tumeroactive and resveratrol. They're specifically done to find compounds to block NF-kappa beta, right? And that's where the evidence is really shown. Now, let's go on to the information here. This is a very important concept. NF-kappa beta can become chronically elevated without further activation because of its own amplifying loop. So when you guys see people that still have chronic inflammation, even though they don't have a known trigger anymore, right? Person who comes in who's eating a whole food diet, stabilizing their blood sugar, doing yoga, doing meditation, praying to feel better, all that stuff, still is inflamed. There's still an amplified loop there. Okay, maybe things have happened in the past, but now they have an ongoing trigger. This is a New England Journal of Medicine paper. It goes into this whole amplifying loop type of pathway. So, they show, like, inflammatory signals, pro-inflammatory cytokines, adhesion molecules, viruses, oxidants, many free radicals. They come in, they turn on NF-kappa beta, you get a gene expression. The gene expression then creates other cytokines like TNF-alpha and interleukin-1A, and that promotes the perpetuating amplified loop. This pathway is the known pathway right now in intestinal permeability. And I'll show you guys the paper on that. So when you guys see these people that have chronic leaky guts, they wonder when they can eat normal again, there's some issues here. You guys understand? I mean, it's not just like they take glutamine for 2 weeks and they get better. Some do, but there's a lot that don't, that they have more of a complex pathway involved, okay? Now, here's the key clinical concept. Once the NF-kappa beta amplifying loop is activated, it may persist as an expression of chronic inflammation unless an active NK inhibitor is provided. Two most naturally powerful ones are resveratrol and curcumin. So let me guys show you some research and papers on this, but let me just stop for a second. So here's the key concept. We know that many chronic illnesses and chronic inflammatory disorders are related to NF-kappa beta activation. Or if you take a look at the biochemistry of chemical responses and you keep going down, 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 down to the DNA, it's NF-kappa beta activation. So that's been linked to pretty much everything at this point, right? Cardiovascular diseases, neurodegeneration, autoimmune diseases, malignancies, everything, right? Now, the problem we have is we have a total disconnect, and we've overassumed two very powerful compounds, resveratrol and curcumin, for the most part in the healthcare system. I'll give you an example. Last month, I was meeting with a PhD immunologist from Scripps, okay? He's one of the main cancer researchers there. He's a UCSD professor, and he was interested into natural medicine and figuring out ways to treat cancer by knowing what natural compounds work and doing more research with it. So we sat down and we met, and we're talking. So he goes, so the topic came up of different signaling pathways that have an impact on different gene expressions and things like that. And I go, yeah, have you ever heard of curcumin? He's like, yeah. I'm all, there's quite a bit of papers on that, right? He goes, yeah, there's like a few hundred, I would guess. I go, yep. Have you ever looked at using curcumin? No. Okay. You probably should. Yeah, you're right. How about, here's another question. Do you take any? No. Are you worried about cancer? Yeah, for sure. Okay. You owe me tea. And then I made him buy me tea. And then we started talking more. But the point is here's a scientist who sees all these papers for a mechanism, sees all the things that block that mechanism, and hasn't put two together. Does that make sense? That's what we do all the time. That's what we're best at as clinicians. All the stuff's out there. We just don't put it together, right? So you guys, turmeric curcumin is really, not very, spice, come on, are you kidding me? But it's very, very powerful, okay? Resveratrol, very, very powerful. And then when they're used together, there's even more effects there. So we know that the pathway for those compounds is specifically on NF-kappa beta gene expression pathways, okay? So naturally occurring polyphenic compounds such as curcumin and resveratrol are potent agents for modulating inflammation. Both compounds mediate their effects by targeting the NF-kappa beta signaling pathway. That's what triggers all the other inflammatory consequences. In this study, they went on to show treatment with curcumin and resveratrol suppressed NF-kappa beta regulated gene products involved in inflammation. We propose that combining these natural compounds may be a useful strategy in osteoarthritis therapy as compared with separate treatments with each individual compound. And here's what they found in this study. They found if they gave them curcumin, they had an effect. They gave them resveratrol, they had an effect. When they put both together, it was severely amplified. And there's 2 other papers besides this. There's 3 papers in literature that show when they mix those 2, that has the most profound NF-kappa beta blocking property. Pro-inflammatory cytokines such as interleukin-1b play important roles in pathogenesis of osteoarthritis and rheumatoid arthritis. In this study, we investigate whether curcumin and resveratrol can synergistically, working together, inhibit the catabolic effects of IL-1 beta. That's the signal that amplifies the loop. Specifically, the inhibition of AMPK, and they found that using both together have the same type of effect. Here's another paper. The anti-inflammatory effects of curcumin included downregulation of gene products that mediate matrix degradation, prostanoid production, apoptosis, and stimulation of cell survival, all known to be regulated by NF-kappa beta. Now, they go on to say prostanoid production. What does that mean? That means produced in pro-inflammatory prostaglandins. Now, if you guys see pro-inflammatory, if you guys do red blood cell analysis for essential fatty acids, and you see higher 2 and 4 prostaglandins, right? Higher amounts of vegetable oil type reactions, even though they're not eating vegetable oils, it doesn't have to be from their diet. Their underlying inflammatory cascade can produce more prostaglandins towards a pro-inflammatory shift like vegetable oils, even though they're not consuming it. Do you guys understand? How the immune inflammatory response oxidizes different types of fats is determined by initial pathways that cause gene expression through NF-kappa beta pathways. That's why you guys, you'll see people who eat nothing but fish and healthy foods and no bad fats, take fish oils and feel better. You guys understand? If you do a dietary analysis, they're not void of any fatty acids. If you give them some, they have an effect, right? If you do a red blood cell analysis of their fatty acid pathways, they seem like they're not consuming any of those things, and they're consuming all these vegetable oils, but they're not. The pre-existing inflammatory cascade causes a shift in their essential fatty acid metabolism, so they have more of these pro-inflammatory prostanoids, prostaglandins. Okay? Then they go on to show in the study, furthermore, curcumin suppressed this NF-kappa beta activated pathway. And more studies on that. Now, this was a great paper that was published in 2011, and they reviewed curcumin. They reviewed the pathways that are involved with curcumin production. They reviewed the mechanisms that are caused by curcumin, and they basically found all of these major pathways here, all these major pathways over here, you guys can see over here on the left-hand side, dampened by curcumin. And this is the NF-kappa beta pathway. On the right-hand side, they found all the things that it can have a difference with, whether it's glycosylated hemoglobin or blood glucose or free fatty acids or inflammation or LDL oxidation. Those are all things that the literature has shown to have an impact with. So, pretty profound stuff. Let's skip that study. Here's another paper on resveratrol. The resveratrol exhibits significant anti-diabetic potential by attenuating hyperglycemia, enhancing insulin secretion, antioxidant competence in pancreatic beta cells of diabetic rats. Several other studies. This is one on human chondrocytes. Now, this was the 2012 paper just recently published, and this was very important for us when it came to developing resveratrol and tumoroactive, but especially tumoroactive. They found that liposomal curcumin, liquid liposomal curcumin, not oral, capsule, were found to be 2-fold to 6-fold more potent than corresponding curcuminoids. Meaning if you take 1,000 milligrams of an oral capsule one, like tablets, or you take 1,000 milligrams equivalent liposomal, you're getting like 6,000, potentially up to 6,000 instead of 1,000 of the effect on tissue, okay? So one of the things that we're always faced with is, here's the thing. We've been doing a lot of effort to try to figure out what do we do with this growing epidemic of autoimmunity. What do we do as a nutritional company? What do we do as education? What do we do as clinicians to try to figure out how to dampen autoimmunity? We're going to get into that a little bit more. When we dampen autoimmunity is for sure inflamed by NF-kappa beta activation, right? As well as other inflammatory diseases. When you do a literature search, you see curcumin and turmeric pop up everywhere. Then you go, okay, well, how much curcumin are we going to give people? Well, you guys, the amount we need is you almost have to get a bowl, open up a bottle with capsules in there, pour in a bowl, and give the guy a spoon. Okay, so it's that's not cool. That's why we had to make a liposomal one, and we had to, because you get 2 to 6 times more of the effect with it. And we had to use curcuminoids and different compounds like black pepper. They activate the response, and then we have a much more powerful, engaging curcumin compound than just using typical capsule tablet-based curcumin. Does that make sense? Okay. Now, the reason why that's so important is because we know that when people have chronic inflammatory cascades, the issue is they have this NF-kappa beta amplifying loop. The inflammation's there, it turned it on, it's feeding itself, even though the triggers are no longer there. And what's been shown to block that from a literature perspective, without any question, without any doubt, is curcumin and resveratrol. They block and dampen this amplifying loop. Do you guys understand that? Okay. So that's one of the key pathways you want to clinically look at. Now, when you have someone who's got NF-kappa beta activation, the list of things that they may have can be profound. Right? And what I want to do is kind of break into each of these different patterns, but most importantly, there are certain vicious cycles that are involved with NF-kappa beta. So let's go through this diagram. And here's what we see over here first. We've already talked about this. NF-kappa beta has immune cell activation. That causes cytokine release, which then has its own self-amplifying loop. Right? Nothing new. That's just what we've been covering. Here, we have a different pathway we're going to get into. NF-kappa beta activates cells in body fat. These are called adipocytes. These adipocytes cause TNF release, cause insulin resistance. Those pathways then perpetuate NF-kappa beta. You guys have all seen people, right? Insulin resistance, work out, eat nothing but vegetables, and still have insulin resistance. This is an NF-kappa beta potentially driven pathway. There is a major breakthrough in the world of immunology, I would think. This past year, there's a new division of immunology that created the World Congress presentations and a journal, and it's called immunometabolics. The study of how immune systems cause weight gain, how inflammation, intestinal permeability, I'll show you some of these papers, cause inefficiency of the body to burn body fat and cause obesity. You guys understand? Because up until this point, it's all been hormonal. A person can't lose body fat, they have a low thyroid, they have too much cortisol, they have too much insulin, right? That's from an endocrinology perspective, not an immunology perspective. So immunologists have looked at the obesity model and go, hey, it's all about inflammation. And I'll show you guys some of those papers and we'll get into that, but really, really important stuff. So one of the things that you're going to see is you're going to see these people that come in that are doing all the right things, that are chronically not feeling well. And when they're not chronically feeling well, you're going to see that they have chronic immune activation or chronic pain, inflammation throughout their body, right? Could be sinus infections, could be joint pain, could be body aches, right? And then they have chronic insulin resistance despite the fact they're eating the way they should and despite the fact they're exercising, right? And then the other thing you're going to see is they have chronic intestinal permeability. Because this NF-kappa beta pathway activation causes continued loss of tight junctions. So you're going to see the tight junction issue, you're going to see the bloating, you're going to see the chronic inflammation, intolerance to foods, right? You guys all seen that patient? Let me remind you who that is. They walk into your office with their bags of supplements. They put it down. You ask them what they're eating, impeccable. You ask them, why are you here? They have a list that can go on for 20 minutes. Okay, now some of those are your autoimmune patients. Some of those aren't in autoimmunity yet. They have this chronic inflammatory cascade. You guys understand? So you go, what are you eating? They have limited foods. They know certain foods cause reactions. And they're like, well, I can't eat wheat, dairy, soy, eggs, nightshades, starch, blah, blah, blah. Okay. What are you taking for your gut? And they have like everything. Probiotic, digestive enzymes, da-da-da-da-da-da. That's an amplified loop. Does that make sense? Check for pathogens. They may not have any, that kind of stuff. So now, you guys, when you see that clinical perspective, okay, that's what you would expect with a chronic activated loop because it hits these insulin pathways, these tight junction pathways, and the inflammatory cascade on itself as a feed-forward system. These vicious cycles then promote each other. The more NF-kappa beta activation they get, the more insulin resistant they get, the more insulin resistant they get, the more tight junction breakdown they get, and this whole thing goes on and on. And we'll get into that. If that continues on, the literature has found chronic NF-kappa beta activation leads to immune dysregulation, which can then be autoimmunity, loss of chemical tolerance, which is the multiple chemical sensitivity issues, and then potentially cancer. Right? Okay. So that's what we want to be aware of. Now, what I want to do now is I want to take each one of these loops and explain them with more detail and show you guys the references and then, put it all together for us clinically. That's all that really matters. Okay. One of the things that we want to get into is this NF-kappa beta pathway related to insulin resistance. Here's the very basics, okay? Inflammation itself creates insulin resistance by altering the insulin receptor substrate signaling pathways. I'll show you that in a second here. But inflammation itself causes insulin resistance. You guys have seen that? And like they eat certain foods that they react to, that are sensitive to, and they get severe sugar cravings. That happens all the time if you clinically look for it, okay? The other thing you guys will see is there's the fat burning pathway. So here's how this works. Body fat, right, is broken down into triglycerol and fatty acids by activation of an enzyme called hormone-sensitive lipase, okay? So we have stored body fat. Let's say a person goes and exercises and works out. When they exercise and work out, they're eventually going to burn up their glucose and glycogen, and then they're going to have to use body fat for energy, right? That activates hormone-sensitive lipase. Hormone-sensitive lipase then breaks down fat to glycerol and triglycerides, which can then be used for energy. Okay? Drugs that are used as, or I should say, people that use ephedra or Malwong or caffeine to burn body fat, that's because those stimulants activate hormone-sensitive lipase. Thyroid hormones activate hormone-sensitive lipase. You guys understand? That's why when there are people that don't have proper thyroid hormones can't burn body fat. People that use stimulants to burn body fat, they can, they get all wired, but it does work for them. And then the other things that we know is chronic insulin, chronic cortisol shut down that pathway. And even more powerfully than those is chronic inflammation. Right? You guys have all seen this clinically? Person finds out they're sensitive to gluten. They go off gluten. They drop 20 pounds. You guys all seen that? Person is intolerant to egg albumin. They go off egg albumin. That one single thing, boom, they drop all this weight. Okay? That's the immunometabolic world. It's the inflammatory cascade causing these things. Now, people that have autoimmunity, you guys, their autoimmunity is promoting this type of shift too. So it's much harder to dampen their effects and those types of effects because they have the ongoing immune overzealousness. So let me show you some of these papers. 2010 paper. The paper is titled, "The Obese Healthy Paradox, Is Inflammation the Answer?" Considered globally, our results support the concept that the development of insulin resistance associated with obesity depends on the activation of an inflammatory cascade, and that IL-6, IL-1 beta, ERK, and NF-kappa beta seem to be the important effectors mediating the inflammatory effects promoting insulin resistance. You guys, because up until now, what is it? It's the amount of starch they eat, the amount of calories they eat. But it doesn't have to be that, and we all clinically have seen that. They don't have to be eating pizzas and high starchy foods to have insulin surges. Their underlying inflammation can do it, okay? And this is a diagram they go in to illustrate. Here they show fat cells. And you guys, fat cells have always thought to be like storage cells for energy. They're not. They're metabolically very, very active. Fat cells are not just storage cells. They produce cytokines. They have activation through NF-kappa beta. They have inflammatory consequences that are released from it and then promote insulin resistance. So here what you see is fat cells. Then you see in this diagram a macrophage creating an inflammatory response. Maybe it's food sensitivity that's activating a macrophage or whatever the case may be. The macrophage releases cytokines. Cytokines activate NF-kappa beta. NF-kappa beta causes more insulin resistance. Now look at these fat cells. What's happening in these pictures? They're getting larger. The cells are getting more insulin resistant. Their cells' ability to break down through hormone-sensitive lipase to fatty acid and glycerol are changing. So now they're not responding to things that would normally cause their fat cells to break. They're getting more insulin resistance. And it's creating this inflammatory, obese, metabolo-immunological type of effect. You guys understand? Okay. Now, when have you guys seen some people have the best responses with insulin resistance and weight loss management? Is when you restrict certain foods, right? Which foods? The ones they're sensitive to. The ones they're inflamed to. You guys have all seen that, right? They cut out a couple foods, they go on a fast, they go on something, they have dramatic change in weight. Sometimes they just change a couple foods out, they eat as much as they normally do, and they don't have, they have profound changes with it, even though they're not hungry. So this is the diagram that you see here. Inflammatory cytokine activation stimulates fat cells. Fat cells themselves produce inflammation. Now here's the other thing. Everyone has different degrees of inflammation. Everyone has different degrees of fat cells. The more fat cells a person has, the more prone they are to inflammation. Okay, so body fat itself is a factor for the amount of inflammation a person will have. Okay? Now, things that are triggering their fat cells for inflammation is another thing to add to fuel to the fire. So Inflammatory cytokines activate adipocytes, fat cells. Those cells release things called adipokines, fat cell protein signaling pathways, or proteins, and then TNF-alpha, which in turn turn off NF-kappa beta, which have been linked to cardiovascular disease, systemic inflammation, depression, infertility, diabetes. The key thing is this pathway dysregulates insulin signaling. They get further insulin resistance and insulin surges, and then they have this ongoing cascade of events. You guys all see that? Okay. So we know that when we see these people that come in that are doing what they need to be doing for insulin resistance based on a dietary model, based on a hormonal model, they don't have high cortisol, they don't have a diet that's high in carbohydrates, they're getting physical activity, and they still have insulin resistance, meaning their glucose is high, or the chief complaint is what? Fatigue after meals. So they get fatigue after meals. Now, some people will only fatigue after certain meals unrelated to their carb load. That's an inflammatory food sensitivity. That's an NF-kappa beta activated pathway. Do you guys understand that? So you'll have a person who goes, I'm just eating salads, and I'm doing okay. This one day I ate a salad, and I was like passed out and tired and craved sugar. What was in your salad? Well, there was egg in there. Do you have an egg sensitivity? I don't know. We'll see what happens when you eat some eggs. Eat some eggs, boom, crash again. The fact they fell asleep and got tired and craved sugar was an insulin response, but it was an inflammatory cascade promoted one. Do you guys understand? Okay. Now, if they have that, here's what you can pretty much bet on. Their NF-kappa beta amplifying loop is plastic. It's developed. It's ready to go. You guys understand that this whole loop has been there for some while because a little trigger like that puts them over the edge. So your goal is to then do what? Block NF-kappa beta aggressively. All right. Now, this is the diagram that you see here, and this was a 2004 paper. Inflammation, the link between insulin resistance, obesity, and diabetes. And they go on to show, different types of dietary intakes, micronutrient intakes. But right here in the diagram, you see NF-kappa beta, you see mental stress, you see infection, you see smoking. All those things then turn off this pathway. You get these inflammatory cytokines produced, and then you get altered insulin signaling. Okay? So very, very important to assess. Now, if you guys look at blood work, you guys ever look at HbA1c, glycosylated hemoglobin? And glycosylated hemoglobin isn't just glucose 6 to 8 weeks average measurement. Glycosylated hemoglobin is the amount of glucose that's been destroyed by a free radical process. You guys understand? Glycosylated hemoglobin. If you guys have some people that will do lab work, they have a normal glucose, but they have very high glycosylated hemoglobin. Those are people that are in this NF-kappa beta loop. If you guys have a person who's got high glucose, but their inflammation is down, the risk of complications is not as bad because all the associated risks with diabetes, like neuropathies, are when hemoglobin A1C is high, not when glucose is high. You guys understand? So if you guys ever do lab work and you see that hemoglobin A1C outside the lab range or close to the lab range, they're getting an inflammatory consequence against their blood sugar, which probably means their systemic inflammatory load is very high. It's not just that their glucose is high, right? You'll see other people that have diabetes, severe high glucose, but not high HbA1c. So those are different. Now, these are the cascades and pathways involved. And this is a review of the things that are known related to obesity, NF-kappa beta, and systemic inflammation. Migraines, GERD, polycystic ovarian syndrome, fatty liver, type 2 diabetes, hypertension, cardiovascular disease. These are the inflammatory consequences. Okay? Now, guess his NF-kappa beta potential, high or low? High. How about this one? I just had to put that one. Isn't that hilarious? Come on. This is some guy's dad, I bet her, Okay. What about hers? High or low? No, high. Because you guys, don't forget sarcopenic obesity. You guys, you got to be very careful. Now, the reason I put these pictures in is because, you guys, this is obvious, right? Severe obesity, right? That's not so obvious, but look at her muscle mass. Does she have any? No. Look down here. Body fat, right? Look at the imaging. Body fat. Not very much muscle mass. That's what you're going to see all the time. Those people have the inflammatory cascade. Okay? It doesn't mean they have to look obese. You can see this in females all the time. You just touch them, they just feel like goo. You know what I mean? Here's your test. Check their deep-headed reflexes. You take that deep-headed reflex, hit their triceps. Check their patella tendon, go to their abdomen, boom. You see jiggle, you see no muscle tone. That could be an inflammatory cascade promoting that pathway. Do you guys understand? Okay. So even though they may seem and appear like they're not obese, they have much more body fat than they do muscle mass. That is an inflammatory-based mechanism. okay? So let me show you some interesting studies here. These results suggest that pro-inflammatory cytokines may be critical in both the development and progression of sarcopenic obesity. And, here's the illustration from that paper going into the mechanisms. These are NF-kappa beta pathway mechanisms, and this is the world of obesity. Now, you guys have to realize, in the immunology world, they don't care about insulin as the prime concept. It's all about inflammation to them. And, everyone sees the world from what their specialty is. So if you're into food and diet, you look at it from that perspective, right? If you're a dietitian. If you're an endocrinologist, endocrinology researcher, you look at hormones causing obesity. If you're an immunologist, you look at inflammation. The fact is they all have an intertwined loop, but we as clinicians have to go, there's a dietary component, how much are they eating versus exercise, right? Is there an insulin cortisol component, and is there an inflammatory cascade component, right? And if there's an inflammatory cascade component that doesn't get addressed, then you may not have the best change with them. And you guys, the most common thing you'll see with these people is they have intestinal permeability, right? Gluten, dairy, egg albumin intolerances, and these people have to go on a really strict anti-inflammatory protocol, dietary restriction to kind of break out of this loop. Okay, we'll get into that as we go on. Now, these are the pathways we know that are based on inflammation. We know curcumin is there, but has curcumin and resveratrol actually been put to the test? Have they actually looked at people that have obesity and inflammation and give them NF-kappa beta blockers like curcumin and resveratrol and see any change? Yes. Let me show you some papers. We therefore conclude that orally ingested curcumin reverses many of the inflammatory and metabolic derangements associated with obesity and improving glycemic control in mouse models of type 2 diabetes. Here's another paper. The interactions of curcumin with several signaling transduction pathways reverse insulin resistance, hyperglycemia, hyperlipidemia, and other inflammatory symptoms associated with obesity and metabolic disease. Here's another paper. Curcumin is reported here as a novel FAS inhibitor, and it suppresses adipocyte differentiation and lipid accumulation, which is associated with its inhibition of FAS. Hence, curcumin is considered to be having potential application in the prevention of obesity. Evidence suggests curcumin may regulate lipid metabolism, which plays a central role in the development of obesity and its complications. Another paper, our study shows that resveratrol is capable of inhibiting lipogenesis. Lipogenesis is fat building. And differentiation of 3T3-LI adipocyte via activation of AMPK, suggesting its potential therapeutic application in the treatment and prevention of obesity. Resveratrol in vitro and at low concentration modulates genes that are related to lipid metabolism, possibly preventing metabolic disease in human visceral adipose tissue. Here's another one. These data point to the potential possibility of use of resveratrol in preventing and or treating both obesity and diabetes. Here's another one. Our results suggest that resveratrol may improve obesity-induced cardiovascular disease and so on. You guys, there is so many more. We just have 2 hours. Okay? So here's what we do know. We know that people have this so-called insulin resistance pathway, not related to just stress, not related to their dietary intake, but to the degree of inflammation. We know that that's generated by the pathway known as activating NF-kappa beta. NF-kappa beta is found in fat cells. That gets activated. Fat cells become more insulin resistant. Pathways that burn body fat become inefficient. You guys understand? Okay. So we know that pathway. Then what researchers have done is go, okay, we know that pathway. Well, we know that's NF-kappa beta pathway. Well, let's use some natural NF-kappa beta blocking agents. And you guys, they put it to the test, and you guys see in multiple studies, and it had an effect. Do you guys understand? Okay. So what this means to us as clinicians is when we see someone who's got the insulin resistance that is not related to dietary intake, we're immediately looking at, obviously, at cortisol and things like that, and insulin modulating that the best we can, but we can't forget the inflammatory cascade. Does that make sense? Now, our biggest clue they have an inflammatory cascade is that they have signs of inflammation anywhere else. If they have inflammation in their brain, what's their chief complaint? Brain fog, depression. As people get inflammation in their brain, inflammation shuts down nerve conductance. You get decreased nerve conductance, you get depression, you can't focus, you can't concentrate, you get brain fog. What's inflammation in joints? Joint. Some people, you go, do you have any joint pain? They go, no. Go, give me 5 squats. They do 5 squats, and you see them go, You go, you have inflammation. They don't know it because they haven't associated that. You guys understand? Inflammation in muscles, muscle aches, muscle pains, inflammation in gut, bloating, inflammation in gut. Their pant size changes, unrelated, right? They go, I just gained 5 pounds, my pant don't fit me, they fit me on Monday. It's not weight gain, that's inflammation. Right? You guys all hear that, right? Patient comes in complaining of those things. That's an inflammatory systemic cascade. Some of these people have amplified loops. Those amplified loops then causes persistent insulin resistance. And if the only treatment is diet, carbohydrate restriction, and just insulin-supporting agents and not blocking NF-kappa beta, the results could be less efficient. Does that make sense? Or not the best outcomes. All right. So anyways, that's this pathway we talked about with insulin resistance and fat. You guys are okay with that? So let's go back to where we are. This is the diagram I really want to get through. So we've talked about the amplifying loop. We've talked about this pathway up here. What I want to talk about is this pathway right through here, which is NF-kappa beta promotes tight junction breakdown, intestinal permeability, which then further activates this NF-kappa beta type of reaction. So let's get into those research papers and show you how this links. So this is a 2010 paper. I won't read the whole thing into, but it shows IL-1 beta causing activation of both canonical and non-canonical NF-kappa beta pathways. And if you go down to the bottom, inhibition of MEK1 activation of the canonical pathway prevented IL-1B increase in tight junction permeability. And the bottom line is this is an NF-kappa beta pathway. This paper is showing that intestinal epithelial tight junction is basically triggered by this NF-kappa beta pathway. Here's an illustration of the diagram. What you see in this diagram is these are the tight junctions. These are what keep the intestinal barrier tight, okay? And the pathway that destroys them is NF-kappa beta activation. Here's the other big deal. You guys, you don't just get a leaky gut from eating inflammatory foods. You can get a leaky gut from anything that turns on NF-kappa beta systemically. Meaning this, if all you're trying to do with leaky guts is fix your diet, you're not going to manage many of these people. Their overall systemic load. You guys, you can have someone that gets exposed to an environmental load, whatever it is, formaldehyde, benzene ring, something like that. That environmental load turns on their NF-kappa beta systemically, breaks down all their tight junctions, and has nothing to do with their dietary intake. You guys understand that? Okay, now picture this. Someone has intestinal permeability, okay? They have insulin resistance surges, and they still overeat carbohydrates, no good enough physical activity. And they don't know why they can't fix their leaky gut. Why can't they fix their leaky gut? Because the insulin surge turns on NF-kappa beta systemically, and at the gut level causes barrier breakdown. Do you guys understand that? Okay? Every autoimmune response, hyperactive immune response, Th1, Th2, creates inflammatory cytokines that break down the gut barrier. Okay, so the fact you have an autoimmunity is going to break down your gut barrier. And this is very important to us because in natural medicine, here's what we do. Leaky guts cause autoimmunity. Here's another way this works. Chronic inflammation of NF-kappa beta causes destruction of intestinal cells, so they have leaky guts. That's why when you go to a group of practitioners, you go, hey, in your chronic patient population, in your autoimmune patient population, how many of them have leaky guts? What would you say? Small percent or high percent? High percent. And it's not just related to their diet. Do you guys understand that? Because if their diet's bad, it's going to definitely add to this, but it doesn't have to be just a dietary thing. So we know that their chronic inflammatory cytokine load, their NF-kappa beta chronic activation, their amplified loop is going to cause this chronic persistent permeability, causes chronic persistent inflammation, causes chronic persistent insulin resistance, right? Okay, which then the chronic systemic inflammation is going to shut down their brain, their gut, then have joint pain, brain fogginess, depression, and all that stuff, right? Now, if you go to them and go, hey, for your depression, I'm going to give you St. John's wort. For your joint pain, I'm going to give you fish oils. And for your bloating and gas, I'm going to give you a probiotic. And for this and this, I'm going to give you that. That may make them function a little bit better, but what are you doing? You're clinically inefficient, and you're not getting a hormetic effect. Does that make sense? There are certain things that we clinically do first because we have a lot of the smoke screen cleared out of the way. And over the years, we found we can block key signaling pathways such as NF-kappa beta. Initially, we have much more profound clinical outcomes. You guys with me? Okay, great. So that's the diagram here. Let me show you some other studies. Now, here's the vicious cycle. Chronic inflammation destroys the gut barrier system. NF-kappa beta activation destroys it. What turns on NF-kappa beta? Well, the first 3 slides I think I gave you go into all the things that turn it on. Okay? Guys, you can have a chronic viral infection and get leaky gut from it. You guys understand that? Okay? You can have an autoimmune in your joints and end up with a leaky gut unrelated to your diet. Okay? Now, once you get intestinal permeability, then these tight junctions open, and then proteins that should not be digested and absorbed get absorbed, right? They cross the barrier system. So normally you eat a protein, it gets broken down to a peptide and into amino acid, and then you get to absorb it. But before that whole system happens, if there's holes in the gut, they can get through, and underneath that there's an immune response, and they have this amplified immunological response. They get more NF-kappa beta, they get intestinal permeability. then that itself can then promote greater activation of NF-kappa beta and even turn on autoimmune diseases. Now, in the literature now, they have papers like this, where it's no longer theoretical. We know for sure that once a person gets intestinal permeability, they can develop autoimmunity, at least in animal models that's been shown. This is one of these animal models. They go in there and they induce intestinal permeability, and these animals develop type 1 diabetes. Okay? That was reproduced. They found similar things with other studies as well. So we know there's studies that have been published that show as you get intestinal permeability, you get autoimmunity. You guys understand? Here's the other thing. You get intestinal permeability from autoimmunity, and intestinal permeability causes autoimmunity. Do you guys understand that? So there's that bidirectional thing. Now, let's say you have someone that comes in that has been diagnosed with rheumatoid arthritis. Do you think they may have intestinal permeability? Yes? Okay. Here's the naive thought. If I fix their gut, I'm going to cure their autoimmunity. No. Now, you may fix their gut, calm down their autoimmunity, but if you can figure out how to calm down the autoimmune signaling pathways, you probably have a better chance fixing the gut and their dampening their autoimmunity. Does that make sense? Because I went to a functional medicine conference last year. I was sitting there, and I wanted to take this pencil and put it through my eye. I just couldn't handle it. I actually ended up going and seeing Wall Street. That's when Wall Street came out. And then again, I was like happy to go back again, but then it took about another hour, and I wanted to stick something else in my eye. Because we simplify stuff to things that aren't real. Meaning like, the reason I was going crazy is because they were going, all autoimmunity is metals. And we're talking about how they chelation and cure every autoimmune disease, and you're going, oh my God, that's whatever. And then it's not real. It's their own illusion of seeing, I don't know. I don't want to get into that. But not to say that can't be effective, but come on. You can't say all autoimmunity is metals. Then they go, if you fix the gut, you fix autoimmunity. You guys ever heard that? It's all out there because it's beyond that simplistic thing. You give someone the 4-hour program, give them probiotics, all these things, but if you don't dampen the autoimmune signaling system, which we're going to get into more, you can't fix these mechanisms that destroy tight junctions. You can't fix the tight junctions. You can't calm down the autoimmunity, and it becomes a vicious cycle. Now, here's another concept. Can an emotional response, can a fight with a spouse flare up in a leaky gut? Yes. How? Activation of cytokine pathways, turn on NF-kappa beta, you lose tight junctions. Kids, different people that have the same degree of emotional insult with their spouse have different degrees of leaky gut destruction. Why? Because of their pre-existing NF-kappa amplified loops. You guys understand? Because there's some, like, you don't return a phone call, they'll flare up. There's some that need to have something dramatically happen to them before they have a severe flare-up. You guys understand? It's their own makeup of different things that trigger inflammation and their own amplified loops. Okay. Yeah, we know intestinal permeability is the big thing to look at. We always use the Array 2s from Cyrex Labs. If you guys aren't familiar with them, the Array 2 checks for bacterial endotoxin, polysaccharide antibodies, actomycin, and occludin-zonulin antibodies. And if any one of these are positive, it just is an indication that they have tight junction barrier breakdown. If you guys aren't familiar with the test, you can go to cyrexlabs.com, call them up. They have a doctor interpretation report, and they can send those to you, and it gives you full details of how the test is interpreted. But basically, any of the markers that show positive, you know that the person has some degree of intestinal permeability, and that's very important for us to look at. Now, check out this paper here. This is related to the immunometabolic aspect of things, and this is a study that shows that gut inflammation is associated with obesity. Okay? Gut inflammation itself can cause obesity. So they go on to say, recent data have proposed that dysbiosis of gut microbiota affects host metabolism and energy storage. Among mechanisms, metabolic endotoxemia, gut permeability, and modulation of gut peptides have been proposed to be as putative targets. Here we discuss the novel findings that may explain how gut microbiota can be involved in the development or control of obesity and associated low-grade inflammation. And you guys have all seen that, right? Someone tries to lose weight with exercise and caloric restriction doesn't happen. Someone goes on a leaky gut type of protocol and program, and then they have weight loss for the first time. That's the gut inflammatory cascade, right? So this is a very key thing for us. This was a study they did looking at tight junctions, and they actually used in this study two different things to see if it would heal the leaky guts. They used the drug, pyrrolidine dithiocarbamate. That's a pharmaceutical NF-kappa beta cancer immunosuppressive drug. Or they used curcumin, and they found they both healed intestinal permeability. Both those target NF-kappa beta. Do you guys understand? Now, you guys, it's not going to ever be standard to give someone a several $1,000 immune suppressive cancer drug for leaky guts. However, they are working on a leaky gut drug right now. It's a zonulin blocker, and that's what they're going to use to treat leaky guts. And when they do, leaky gut's going to be a common medical condition, but it isn't right now. They need a drug for it first, right? So they can they can sell it. Okay, but right now that's what's going on. You guys, and this is what's the scary thing is they're just working on the drug. Once the drug is developed, they'll have it, and they're converting resveratrol into a drug, a synthetic form. This past year, they converted not a few years ago, they converted essential fatty acids to a synthetic version and used it as a cholesterol drug. It became a multi-billion-dollar drug. Now the drug industry is realizing they can find the most effective natural compounds, make them synthetic, and create a new drug. Once they do, the natural compounds become on the alert for the FDA as a drug, and then they get taken off the market. So that's the future we have. All right? Now, the things you start to see they're trying to make drugs out of are the most profound compounds. You guys understand? And resveratrol is right up there with this. So what we want to kind of put together here is, here's what we've gone so far. Tight junctions create inflammation. Inflammation causes breakdown of of the leaky gut type pathways. But you guys, anything that turns on NF-kappa beta can cause barrier gut breakdown. Do you guys understand that? So it's not always dietary. That's why the enigma shouldn't be an enigma. When someone comes in and their diet's perfect and they still have a leaky gut, you shouldn't be like, wow, that's so weird. Anything else that's causing activation of that pathway can break it down. It's a very vulnerable set of tissues there, right? You can have people that have chronic inflammation causing their insulin resistance. You shouldn't be puzzled by the fact that they don't eat high starches and still eat a meal and pass out. That's an inflammatory cascade. Does that make sense? Okay. It's only an enigma when you think linearly, when you think about what the mechanisms are physiologically and what we understand about NF-kappa beta pathway, all those things are to be expected, right? Now, if you guys aren't ahead towards diabetes, they're brain fogged and tired all day, they crash out in the afternoon, they exercise and their body aches, they don't recover very well, they have infertility, they have abnormal cycles, okay? They have all that stuff. They wake up every morning and have a green drink and then do yoga. Then they eat very high quality protein throughout the day with organic vegetables and drink tons of water all day. And you eat every few hours. And they're in your office. And they wonder why they have all the stuff. It is not an enigma. What happened to them? Their amplifying loop is filled up. Now here's the ugly thing. We know we can use things like curcumin, resveratrol to block this, especially at very high doses aggressively. However, some people have a plastic loop that you cannot unwind. You can try, but you just can't do it. You guys will see some of these people that have lupus, you can't unwind it. You know, I had this one patient, freaked me out. He didn't actually become a patient, he came as a consult. He came in, he had a rare autoimmune disease where his immune system was attacking his skin. He had no more skin, so he comes in a bodysuit. Okay? Son brings him in, he's in a bodysuit. Already you're going, oh my God, right? He takes off his glove. You can see his bones, you can see his cartilage, you can see all the stuff. And I'm just thinking, please don't take off your mask. You know, it's too much. But this is a guy who was on immune suppressive drugs. He was taking NF-kappa beta blocking drugs. He was taking high amounts of corticosteroids. It wasn't doing anything for it, and he was still getting chewed up and deteriorating away. That's a chronically activated loop. Okay? Curcumin, resveratrol, not going to do anything. Okay? So, you know, these are models that we know we can implement, but not everyone's going to have the magic scenario clinical outcome, right? We got to try, and then the outcome they have is unpredictable, right? Now, here's the thing. If you guys are going to use highly saturated curcumin, resveratrol, like we use Tamaractive or Veractive, you have to use whatever it takes in the beginning to block the inflammation. You guys understand? Because like they read the box, it might say take 5 milliliters twice a day or something like that. But in reality, use enough to bring down the loop. Once you bring down the loop, they don't need that same dose again. Does that make sense? So you have to go aggressive enough to dampen the loop inflammatory cascade, and they usually don't need as much. Now, let me show you the other things that are involved here. So by the way, this is a diagram that's showing how these two vicious cycles here, let me go back. Remember this diagram? Insulin surges turn on NF-kappa beta, NF-kappa beta turns on insulin surges, and then tight junctions turn off NF-kappa beta, NF-kappa beta turns on insulin surges. These two cycles are represented in this diagram over here, put together. So you see IL-6, cortisol can be promoted by insulin surges. Insulin surges can be promoted by chronic NF-kappa beta inflammatory cascades through this pathway here. These mechanisms here break down include zonulin, the tight junctions. You get intestinal permeability, you get dysbiosis that creates lipopolysaccharides, which then turn on NF-kappa beta, and you get this vicious inflammatory cascade. You guys with me? Okay. Guys, all your autoimmune disease patients are going to come in with the perfect diet, probably, that still have chronic leaky guts and still have chronic insulin resistance and have chronic inflammation. Do you guys understand that? And if you try to handle them from the simplistic model, it won't work. You got to block signaling pathways, which we'll get into with more detail, but NF-kappa beta is a major one. Now, we didn't talk about this pathway over here, which is the biotransformation pathway or the detox pathways, okay? Those also get severely impaired in NF-kappa beta activation. Let me make it very straightforward. Chronic NF-kappa beta activation has an amplifying loop. Everybody good? That chronic amplifying loop is going to cause chronic insulin resistance tendencies. That chronic insulin resistance amplifies the loop even further, right? So you're going to see these blood sugar disorders in these chronic inflamed patients, unrelated to what they're eating. That is just carbohydrates, but foods that trigger inflammation are more of an issue with them. Then you're going to see that they have leaky guts. And again, unrelated to maybe what they're eating. They may already be on a gluten, dairy, albumin-free diet or whatever, but they still have intestinal permeability to some degree. They eat those foods, they get worse, but they still have that loop. Then you're going to see that itself, they're just chronically inflamed. So all those things are there when you see the NF-kappa beta loop. So they're going to come in with the symptomology of what? Fatigue after meals, sugar cravings, tired, joint pain, muscle aches, all that stuff, right? Okay. The other pathway that it impacts is their detoxification pathways. Phase 1, phase 2 pathways also get hindered in this chronic NF-kappa beta activation. This model that we're going into was the reason why Apex put together an entire protocol called Repair and Clear. It's a three-phase program. You guys have little booklets or little pamphlets in your handout, and it starts with blocking NF-kappa beta, working on leaky guts, and then impacting detox pathways in a sequenced way. Okay, we'll go into that towards the end of the presentation, but I just wanted you to know there's a clinical application and why it was put together. So let's get into this hepatic biotransformation pathway. In the literature, they don't call what we do liver detoxification. Okay? They call it hepatic biotransformation. So if you guys do a literature search for liver detox, you won't find anything. You're going to find it all under hepatic biotransformation or hepatic detoxification, not detoxification, detoxification. That's how it's listed in the peer-reviewed literature. Now, we know that when people get environmental insults, not every environmental compound is cleared out through hepatic pathways. Do you guys understand that? Yes, you have only so many cytochrome P450 enzymes, you have so many phase 2 enzymes. We can't clear everything out of our body. The liver's job through phase 1, phase 2 pathways is to take substances that are like fat soluble, for example, like a hormone or something, and then make it into a water soluble compound so we can eliminate it. The body can't do that with things like mercury. It can't do that with benzene rings. It can't do that with formaldehyde. Do you guys understand that? So we have a list of environmental things that our liver can clear and a list of things it has no potential to ever clear. Right? Okay. When a person gets chronic NF-beta kappa activation, one of the things that happens to some people is they lose what they call in immunology loss of chemical tolerance. They can't handle any chemicals anymore. They can't even handle perfumes and shampoos and carpets and any of that stuff. Okay? That has nothing to do with the liver phase 1, phase 2 pathway and everything to do with immunological hyperactivity. Do you understand? Particularly through NF-kappa beta pathway. So, one of the things that you guys want to realize is if you get exposed to an environmental toxin, which we all will, one of the things that's going to devastate our response to it is our baseline chemical tolerance. And our baseline chemical tolerance is directly related to, guess what? Or pre-existing NF-kappa beta amplified loop. The more amplified loop you have, the more likely an environmental insult is going to put you over the edge. You guys understand? Okay. It could be anything. I mean, you could have 2 people, 3 people living in the same apartment. There's an environmental something there, right? Loaded with formaldehyde. Or you get a bunch of students going to anatomy labs, they're playing with formaldehyde all day with these dissections. Some people get really, really sick. It's not a liver detox issue. It's a NF-kappa beta, immune activation, loss of chemical tolerance type of perspective. Now, here's the key thing. Environmental triggers that come in that don't go to the liver turn on NF-kappa beta. This is a paper that was related to dioxin. And dioxin toxicity, it could be any of it could be formaldehyde, it could be benzene rings, it could be plastics. Those compounds have been shown to basically trigger on the NF-kappa beta pathway. One of the best visual expressions of this was Yushchenko. You guys remember him? He was running for president of Ukraine, right? And he was on the US side more than the Soviet side or Russian side. And the Russians poisoned him during his campaign. And this picture from the left to the right is 2 weeks apart. 2 weeks. They poisoned him with dioxin. Does dioxin go through phase 1, phase 2 pathways? No. There's no cytochrome P50 enzyme to break down dioxin or phase 2 pathways to clear it. Turn on NF-kappa beta. You guys see the severe amount of inflammation he has throughout his skin now? Okay, it's just being destroyed. Do you think he's gained any body weight in the past 2 weeks? Absolutely, right? You guys can see the difference there? Okay. I mean, you can see more chins here than here. I mean, he's gained weight. So just that inflammatory consequence immediately had a devastating effect on him. And by the way, he was running for this campaign after he got poisoned. He had to make a speech. And they gave him a shot of epinephrine to get him to go and do a speech. He did like a 30-minute speech, and then he passed out, and he almost died. And you know, it was a pretty ugly thing, okay? But this is an inflammatory consequence. So you guys, when you see people that get exposed to environmental issues, you know, it's the most thing clinicians will do. As soon as they hear environmental insult, what do they jump into? Liver detox. Oh, environmental liver milk thistle. It's like almost like a conditioned response, you know what I mean? However, environmental insults, you should be immediately thinking NF-kappa beta. NF-kappa beta activation, right? Then creates this amplifying loop. Can someone get an environmental insult and then develop insulin resistance? Yeah. Yes, unrelated to their carbohydrate intake. Can someone get an inflammatory cascade to their environmental insult and then develop permeability unrelated to their dietary intake? Yes. You guys understand? Meaning there should never be the enigma weird patient when you see those things. That's normal physiology related to a pathway. If you see those things, then the question is, how do you block NF-kappa beta most efficiently? Where's all the evidence? Resveratrol, curcumin, also used together, high concentrated doses. Does that make sense? So that's where we had a lot of our applications towards. So these are some papers you guys can see related to NF-kappa beta environmental insults. I'm not going to read all these to you, but I just want you to know that you guys have these in your abstracts. Now, here's the other interesting thing. As anything turns on NF-kappa beta, okay? You get an inflammatory consequence. The inflammatory consequence itself shuts down cytochrome P450 phase 1 pathways. You guys understand that? Okay? Something turns on NF-kappa beta, liver pathways become sluggish. Now, one of the things we're going to get into, again, is this repair and clear program. Repair and clear, we block NF-kappa beta first, phase 1. Phase 2, we do a leaky gut diet. Phase 3, we do hepatic biotransformation, nutritional support. That's the sequence we do to break people out of like the so-called loop that we're talking about, okay? Or attempt to. Because everyone has different degrees of plasticity. We can attempt to change, but not everyone is going to change, you know? That's the reality of practice. But we got to try, okay? Now, and then, you know, you get more papers on this. Now, here's the summary of the gut and liver pathways involved with this, okay? So once again, you have the inflammatory triggers that you see in this diagram: processed foods, genetically modified foods, partially hydrogenated fats, allergic and sensitive foods, environmental compounds. They turn on NF-kappa beta. NF-kappa beta then does what? Releases cytokines like IL-1, then which do what? Feed itself. So now you have this feed-forward amplified loop. You guys all with me? That's what this diagram is showing right here, this feed-forward amplified loop. This feed-forward amplified loop then has consequences in two major areas. One is the gut. One is the hepatic detox, what we call, or hepatic biotransformation pathways. These NF-kappa beta IL-1 pathways break down the mucosal tight junctions. When they break down the mucosal tight junctions, you get a leaky gut, right? What we call slang leaky gut. Then those inflammatory consequences from the intestinal permeability feed NF-kappa beta, and you're right there again. You guys see that? Okay. And they could be, again, once again, on a really anti-inflammatory diet, but they still have intestinal permeability. because the loop is there. This NF-kappa beta pathway itself creates inflammatory cytokines, which then suppress hepatic biotransformation, like the study I showed you. So now their liver's ability to clear out phase 1, phase 2 compounds is now hindered. As you compromise hepatic phase 1, phase 2 clearance, as you increase the NF-kappa beta loop, as you get intestinal permeability, what kind of consequences do you get? Joint inflammation, vascular constriction, neuroinflammation, weight loss suppression, gastrointestinal inflammation, muscle inflammation. Just look at the last few symptoms. Do you ever see a patient with all those? Yeah? When you see that patient with all those, eating a perfect diet and exercising, that's today's diagrams. And how common is that? It's pretty common, right? I mean, we see a lot of that stuff. You know, all of us do. Southern California, meaning patient population we see here is at least more likely to eat well. If we were practicing in like Alabama or somewhere like that, I mean, it's a different world, okay? But we see a lot of people doing all the right things but still have these type of consequences. Okay, now this is the insulin resistance pathway. Now let's get into this NF-kappa beta pathway related to autoimmunity, okay? So let's go back to our core diagram and just review the key concepts. So anything that we know associated with inflammation turns on NF-kappa beta. NF-kappa beta stimulates fat cells. Adipocytes then release inflammatory cytokines. They then further cause dysregulation in insulin surges. The inflammatory consequence shuts down hormone-sensitive lipase. They can't burn body fat efficiently, so they get further insulin resistance with inability to lose body fat, right? Again, not related to their carbohydrate intake, not related to the physical exercise, related to inflammation, right? The whole immunometabolics type of work that is being studied now in immunology. This other side, the NF-kappa beta pathway, again, unrelated to what they eat, just whatever activates it, has been shown to cause intestinal tight barrier junction breakdown. You get intestinal permeability, you get more NF-kappa activation, you get this inflammatory consequence. That whole loop creates further inflammation that becomes systemic, right? And the brain causes neuroinflammation, brain fog, depression, joints causes muscle aches and pains, and the gut causes bloating, distension, right? All those things. So you get the whole cascade of stuff. In the liver, it turns on this inflammatory cascade, which then leads to people developing chemical intolerances. It starts to shut down phase 1, phase 2 pathways. And now they're stuck in this inflammatory loop, right? Then they go and see someone and go, I want you to do heavy metal chelation. What do you think? Good or bad idea? You guys understand? Just you look at the mechanisms and go, wow, why would you do that? They have loss of chemical tolerance, they're totally inflamed, they don't have a barrier system. And you guys, most of the studies are now showing that when a person gets intestinal permeability, there's a systemic zonulin release. This is a peptide. The systemic zonulin release has been associated to breakdown of the blood-brain barrier too. So it's not clear, but the evidence is kind of A may equal B, is that if you get intestinal permeability, you probably have blood-brain barrier breach too. So, you know, then we look at the models that have been used, it's kind of very sensitive for these things. Now, if these vicious cycles continue on, you have chronic immune dysregulation. This is where you get loss of self-tolerance related to autoimmunity, multiple chemical sensitivities, and then loss of cellular apoptosis and things like that. You guys with? You guys understand? Okay. Now, you guys, just to give you a clue, what we're doing next month. Next time we do the 2 hours, I'm going to show you guys the 20 most common autoimmune diseases that are out in the clinical world and how they clinically present with symptoms and signs. And then we're going to get into all the literature related to loss of self-tolerance. So it's going to kind of add to what we're building up on, okay? Now, when we look at the autoimmune signaling pathway, here's what we know. We know that the autoimmune triggers are very much related to NF-kappa beta activation. And when you look at the research, what they're trying to say is if they can find a clinical way to dampen NF-kappa beta pathways, they can dampen autoimmunity. They are already doing that in the conventional model with very severe progressed autoimmune diseases. They don't do it with early autoimmune diseases because the NF-kappa beta drugs they use, again, cause such severe immune suppression that they may die from a very basic, trivial common cold or something. You guys understand? But this is the goal that they're trying to do. Now, what I want to do is I want to show you these abstracts, but I want to skip to the end and go to this diagram first and then also end with the diagram. Here's the thing. You guys, when you look at the world of natural medicine and how they look at autoimmune disease, it's a very linear, simplified, philosophical model, right? All autoimmune diseases are parasites. All autoimmune diseases are stealth pathogens. All autoimmune diseases are environmental. Stuff like that, right? So you got the heavy metal people blaming it all on heavy metals. You got all the gut people blaming it on parasites. You got, the whole world, okay? but it's not the contemporary understanding of autoimmune disease in the immunology world. Okay, so let's just say we do this. We take the world of natural medicine and nutrition and its approach to autoimmunity, and we just put it aside, right? Because we want to do things that are not the 1960s model of nutrition, not the philosophical world. We go in and dive into the immunology literature. PhD immunologists, unrelated to treatments, philosophies, bias, trying to figure out what's going on with the autoimmune reaction. You guys with me? Okay, this is the summary of that. Let me explain this to you. So what we know is when someone gets an autoimmune disease, their immune system becomes overactive. But it tends to be overactive on either the Th1 side, what are T cells, or Th2 side, which is the B cells. And they call these in the immunology literature as Th1 dominant or Th2 dominant autoimmune diseases. You guys understand? Okay. So someone gets an autoimmune disease, their immune system is going crazy, going overactive, and it's attacking self-tissue because they lost self-tolerance. It's either on the Th1 side, T cell exaggerated response, or a B cell exaggerated response. Okay? This is very important to us as natural medicine practitioners because certain natural supplements stimulate Th1, right? Maitake, echinacea, a lot of those immune-enhancing stuff stimulates Th1. Things that are like antioxidants, potentially, acai, grapeseed extract, pine bark extract, stimulate Th2. The most devastating thing you can ever do to an autoimmune disease patient is not know that list and give people compounds that have those ingredients in it and promote further autoimmunity. Okay? A lot of times patients already know what it is. They try to take a product, they totally crash, they go, I'm never taking that product again, but the clinician may not know what's going on. You guys understand? So we know to look for these things and we know how important this is for us. Okay. Now, we have this underlying Th1 or Th2 dominance. What activates that Th1, Th2 dominance is activation of not Th1 or Th2, but Th0, naive T helper cells, which is turned on by NF-kappa beta. You guys get that? NF-kappa beta turns on naive T helper cells to shift into a Th1 or Th2 shift. The greater their Th1, Th2 shift, the greater immunological activity, hyperactivity that they have. You guys good? Okay. So then we're going to talk about applications clinically. Now, there is a Th3 cell called the regulatory T cell. And the job of the regulatory T cell is to dampen their Th1, Th2 shift. It's something that we want in high amounts of activity, right? Things that have been shown to stimulate Th3 cells are opioids. So people who laugh, people who are happy, people that feel loved have greater opioid activity. And what do you guys see clinically with those type of people in autoimmunity? Someone loves them, someone cares about them, they're happy. What happens to their autoimmunity flare-ups? They calm down. It's having an opioid effect. Pharmaceutically, they use naltrexone, which is an opioid, to try to dampen it. I mean, has limited effects for some people, but it's an attempt to get an effect on Th3. Nutritionally, vitamin D, things that raise glutathione. We use Ultra D complex, glutathione recycle. We'll get into protocols a little bit second, but those things have been shown to have an impact on activating Th3. So just take a look at the model so far. Clinically, you have a Th1, Th2, which is really expressed through activation of NF-kappa beta, right? And then you have a Th3, which dampens that effect. So let's say you do this. You get this patient who comes in, they have severe debilitating rheumatoid arthritis. They come into your office, they have a claw hand, the whole body hurts, but they have this claw hand, they can't write anymore, they can't type anymore, they have to drive with one hand, their hand's always in pain, they're not going to movies, they're not going to plays, they're not going to social events, they're not playing any sports, they're just trying to not suffer throughout the day. You guys understand? Like real life. This person goes, I don't know what to do, but I'm deteriorating away. What are you eating? Perfect diet. They're off wheat, dairy, soy, eggs, inflammatory foods, nightshades, all that stuff. Okay? They eat. Every time they eat, they pass out. And when the times that they get more tired eating, they notice their joint pain's worse. What's that? NF-kappa beta insulin surge pathways. I tell you that sometimes when they eat, they just get bloated and their pants don't fit them anymore. What's that? NF-kappa beta intestinal permeability unrelated to what? Their dietary protein intake. You guys understand? Okay. Now they're stuck in this pain scenario. What would be some strategies you'd want to do? You find out that they're taking a bunch of supplements, both on the Th1, Th2 side. Well, you're a little bit concerned right away. Okay, because they could be taking something that's promoting more of their flare-ups. They don't know what it is because they're so desperate taking everything now. So you guys, clinically, you'd want to what? Dampen NF-kappa beta, figure out their Th1, Th2, right? Stimulate the regulatory T cells as much as you can, vitamin D, glutathione building stuff, and kind of get that system balanced out. Then you find out if they eat less, they don't have as much insulin surges, and you kind of calm that down, and you're starting to calm down the expression of their autoimmune flare-ups. You guys understand? If you calm down the expression of autoimmune flare-ups, what do you do with their insulin resistance? What do you do with intestinal permeability? You probably calm those things down because it goes through the NF-kappa beta signaling pathway. Make sense? Okay. So here's the other thing. Then you have this Th17 pathway. You guys with me here? Okay. Th17 is actually promoted by NF-kappa beta. NF-kappa beta turns on inflammatory cytokines, especially interleukin 6 and TNF-alpha. They then stimulate T helper 17, which produces interleukin 17. And this is the Th17 pathway. The greater interleukin 17 they have, the more destruction they have from their existing autoimmunity. You guys understand? Okay. By the way, resveratrol has been shown to block Th17. I'll show you guys some papers. And it blocks NF-kappa beta. So Th17 gets activated and it produces interleukin 17. The interleukin 17 doesn't destroy anything. It then turns on inducible nitric oxide synthase, which is the free radical that will then destroy whatever the antibodies have tagged. If there's myelin antibodies, destroys myelin. If it's cartilage antibodies, destroys cartilage. If it's beta cell antibodies, destroys the pancreas. Do you guys understand? Okay. So, you guys, I'm just summarizing 4 years of what it took me to fill out in the literature for you in 10 minutes, okay? So here's what it is. You have an NF-kappa beta amplifying loop. It turns on naive T helper cells, Th0 cells to a Th1, Th2 shift. There's variables that cause shifts there too. That's dampened by Th3. The amount of Th1, Th2 destruction they have is further perpetuated to the degree of destruction they have by the amount of IL-17 and INOS activation destruction. Okay? Now picture this. You do a clinical strategy that dampens NF-kappa beta. You do a clinical strategy to stimulate regulatory T cells. You do a clinical strategy to dampen IL-17. What are you doing to autoimmune signaling pathways? You're dampening it. Does that make sense? We're no longer going, all autoimmune diseases are parasites. It's naive. You know, parasite can trigger NF-kappa beta, but it's not the mechanism. Does that make sense? Because when someone is suffering, they don't have to have a pathogen there anymore. There's just things that have turned on to this loop. Okay? So this is how we look at these protocols, and these are what we do in our Repair and Clear program. Once again, Repair and Clear program is to dampen NF-kappa beta, increase Th3, dampen interleukin 17, modulate INOS. You guys understand? It's really well thought out. We're trying to make it simple. Now let's go back to the studies that we skipped over, and I can show you how these are involved here. Okay. So this is the pathway related to NF-kappa beta activation, autoimmunity type 1. Let me share with you something I read a couple months ago. There was a paper that they did on, I'll show you guys this next 2-hour talk. There's a paper that was published that looked at type 2 diabetics. Okay. They checked them for islet cell antibodies, pancreatic autoimmunity. 20% of known type 2s had actually type 1. 20%. You guys, whenever you guys see a patient come into your office that is normal weight, has no reason for being diabetic, it's potentially autoimmune. You guys understand? How far do you think they get with a carbohydrate-restricted diet? No, they become the enigma. They don't know what to do with them because they're not eating sugar and starch. As a matter of fact, they're athletes, they exercise, they get no change. What would happen if someone went in there and goes, you know what, we're going to block NF-kappa beta, we're going to increase your Th3 activity, we're going to dampen IL-17. Probably have a closer potential to have some kind of clinical result that's positive, right? Okay. Anyway, so these are related to autoimmunity and NF-kappa beta gene relevance, and you'll see several of these papers in here. I'm not going to read these all to you, but check out this paper here. Curcumin suggests the potential for treating autoimmune patients in this one study. This is a study they did with multiple sclerosis. Just read the paper, the title, oral resveratrol reduces neuronal damage in a model of multiple sclerosis. Now, why would it do that? Well, resveratrol has been shown to block NF-kappa beta and block Th17. We used to think resveratrol was a Th2 stimulator. We were wrong. It's not. It's an NF-kappa beta blocker, Th17 blocker. Here's another paper. It's a paper that shows that resveratrol, look at this, increases activity of Tregs. What are those? Th3. They balance out the Th1/2, and even though it also increases development of Th17, meaning that it modulates this expression in a positive way. And you'll see these numerous papers in here. Here's one on myocarditis and curcumin. Here's another one on neuroprotective effects of turmeric. Curcumin has bright prospects for the treatment of multiple sclerosis. So they were actually using these compounds in autoimmune disease research and seeing some positive outcomes, right? Because there's not many things that show positive outcomes with autoimmunity, just so you know, okay? Here's one on curcumin. Now look at what they did with this one. They found that curcumin turmeric significantly decreases binding of autoantibodies. This is an entirely different mechanism. You guys understand what's going on here? Let me explain this. When you lose self-tolerance, your immune system starts to tag your own tissue as something to attack. And the way it starts to promote that immune response is it makes antibodies for self-tissue, right? Which you can measure. Thyroid antibodies, islet cell antibodies, cartilage antibodies, right? Stuff like that, okay? Neurofilament antibodies. But the antibodies don't destroy anything. All the antibodies do is attach to the tissue that the immune system then knows that it needs to be destroyed. So like kind of as a tag, protein tag to the protein, the immune system is now associating as being like a bacteria or a virus that it then goes and destroys. You guys understand? What curcumin has been shown to do is not allow the antibody produced by the B cell to actually attach to the tissue. If it doesn't attach to the tissue, it's not going to get attacked, even though it's being made. Look at this study, curcumin, binding of antibodies from Sjogren's, 40 to 70% respectively, SLE, lupus, 50 to 72% respectively, and you guys, these are pretty amazing. And they conclude in this paper, thus we suggest that multifaceted heat-solubilized curcumin can ameliorate autoimmune disorders. Pretty profound stuff, okay? And you guys, more of the same as these papers go on. So, do you guys understand the major goals here? Now, the goals that we use for autoimmunity are the same thing as when people have subtle chronic inflammation. When someone has subtle chronic inflammation, we want to dampen these same pathways, right? When they're autoimmune, we want to do a greater job of doing these things, okay? Now, the program that we use to hit this ugly vicious cycle, meaning the ugly vicious cycle of NF-kappa beta being turned on into an amplified loop, causing insulin resistance, causing hepatic biotransformation, causing intestinal permeability issues, is the Repair and Clear program. The Repair and Clear program, there's a little booklet we made for it. That's the clinical approach that I do in my office to deal with these types of cascades. Now, that is not, this protocol that we call Repair and Clear isn't for everyone, but when you see someone in this loop, you definitely want to consider it, okay? Now, this is the goal of that program. Support healthy mucosal barrier integrity, support healthy blood-brain integrity, support healthy bronchus barrier integrity, support healthy hepatic biotransformation pathways, support healthy glutathione recycling, minimize Th17 activity, support healthy Th3 regulatory T cell activity, balance Th1, Th2 polarity, support healthy blood sugar balance, minimize activating dietary peptides and antigens, balance nitric oxide isomer expression. The goal of that is to support healthy anti-inflammatory mechanisms, support healthy self-tolerance, support healthy chemical tolerance. Everybody with me? Okay. So let's recap these and we'll put into the takeaway clinical application here. So the key thing you have to understand, once again, is all the things that we're associated with inflammation can cause a plastic change to create what's known as a TNF-alpha, NF-kappa beta amplified loop, right? This loop then perpetuates itself. The triggers may not have, they don't have to be there anymore. However, when the loop is there, they create so many mechanisms that cause persistent self-amplification of it, like the cytokines, like the insulin surges, like the intestinal permeability, like the ability to clear out phase 1, phase 2 compounds, right? Those are all things that add to an ugly picture. Key concept, NF-kappa beta becomes chronically elevated without further activation because of amplifying loop. Key clinical concept, once the NF-kappa beta amplifying loop is activated, it may persist as an expression of chronic inflammation unless an active NF-κB inhibitor is provided. The two most naturally powerful inhibitors of NF-kappa beta are resveratrol and curcumin. Meaning is, if you go on PubMed, do a literature review, nothing even comes close to the amount of research that these things have on blocking this pathway. Now, we also know if it's liquid, there's a 2 to 6-fold increased potency. There's curcuminoids added to it. There's increased potency. And if you add them both together, you have a synergistic effect on blocking NF-kappa beta, right? That's what we know from what's been published. This is why Apex has tumeroactive and resveratrol-active, right? These are liquid. They have a syringe delivery. There's samples for you guys here today if you guys want to try them in the back. And you basically stick the syringe on. It's not a needle syringe, it's just this syringe you put into the top so you can extract out the exact amount of milliliters, right? You just pull it out. If the patient's the only one taking it, easier just to have them put the syringe in the mouth and just squirt it in. You can try to put it on a spoon, it can get messy. Just, pull it out, put it in your mouth, squeeze it in, you get the dose, okay? Now, you're gonna see in the protocols, it's gonna say 5 milliliters twice a day, but quite honestly, some people have severe inflammatory loops. You give them more. Whatever you need, okay? How much do you need? What is it? I don't know. You see, here's an example. They have joint pain. Take enough so your joint pain's reduced. What does that mean? Don't know. Try it. Try 3 syringefuls 3 times a day or something like that. Try 2, try 1. Let's just see where it gets to. You have to realize if people have a plastic amplifying NF-kappa beta loop, you're gonna need to hit it at the high dose, and then you probably won't need to hit it to that same high dose continuously. Does that make sense? But you may need to do it for a few days and block that whole thing down, all right? Now, the key thing about that is because resveratrol curcumin block this amplified loop, and we showed numerous papers on that throughout the presentation. You guys can read more about them if you go to PubMed. And we went over these vicious cycles already. We know that we have the insulin resistance one, the leaky gut one. I'm going to skip through that. And then we know we can block these Th1, Th2, Th3, Th17 things in a modulated way. So the Repair and Clear program is broken down into a basic one and a comprehensive one. And here's the thing with this. The basic one is for people who have chronic inflammatory clinical responses. The comprehensive one is really those that have more of an autoimmune type of response. You guys understand? So you can kind of decide where to go. Now, there is a lot of supplements recommended here. And if you have a patient doing the basic program, there's different phases of it. And you guys will see on the next slide, it tells you what the patient will need for the 6 weeks. 2 Clearvites, 4 Ultra Ds, 1 Repairvite, 1 Strengthia. So if you guys were thinking about what a patient needs to do the whole 6 week, it's already listed for you in a slide. Okay, so you know what they're involved with. And the way this works is week 1, we shut down or try to clinically have an effect nutritionally to dampen NF-kappa beta. Does that make sense? So we use resveratrol-active, tumeroactive, and Ultra D complex. Ultra D complex is an emulsified vitamin D, which is a regulatory T cell support in cod liver oil. So you're giving him like a fish oil, at the same time you give him high dose D, you're giving him resveratrol, you're giving him curcumin, you're having that pathway dampening effect. Do you guys understand? That's step 1. Step 2, or I should say phase 2, which is weeks 2 and 3. And you guys, it says weeks 2 and 3 here, but quite honestly, it could be months 2 and 3. It really depends on what you clinically feel is the length of time. We just made everything 6 weeks, but you as a clinician can decide they need to be longer in the second stage, right? Okay, now, what we do in this stage is now we go into the leaky gut thing, the leaky gut protocol. Now we have them avoid grains, starches, lectins, nightshades, dairy, gluten, right? Because they're all inflammatory things someone with intestinal permeability cannot tolerate at all if they're trying to heal it. They're going to be encouraged to eat whenever they're hungry. They can eat vegetables, they can eat fruits, they can have meats, just not the inflammatory protein triggers. They're going to take Repairvite. It's a powder to help support their leaky gut. Things like glutamine, marshmallow extract, right? N-acetylcysteine, all the things that have been published to have an effect are in there. They're going to take Strengthia, which is a probiotic. The probiotic strains that have been shown to penetrate the pH of the stomach and actually get to the colon are there. Then they have these GI synergy packs, which has natural compounds that have natural properties against bacterial yeast overgrowths, parasitic responses. So it just provides those natural supporting things. Okay, so we call it a critter packet. Okay, because many people with the intestinal permeability have yeast overgrowth and bacterial overgrowth and things like that, right? So they're going on this restricted diet as they're continuing to block their NF-kappa beta pathway, as they're supporting their intestinal permeability. Okay? That's the weeks 2 and 3. And then weeks 4, 5, and 6, we put them in our Clearvite program, which is a powder really designed for phase 1, phase 2 support. They take this packet called hepatosynergy, and they still stay on their NF-kappa beta blockade substances, the Tumero was very active, to try to calm down the whole cascade. Does that make sense? Okay. Now, you can look at the timelines differently, but if someone who's just got severe inflammation, they're in pain, suffering, we just made it as like a standard 6-week thing. You can make it more aggressive. You can do it longer. And because I find, for me personally in practice, it's always better to be most aggressive when you first see a patient. Because you know what I mean by that? Meaning if you kind of dibble-dabble with a person, like you dibble-dabble, go, I just want you to take a fish oil, see how you do. You do that, they don't feel better. Then, I add this to it. They add that to it, doesn't feel better. Then you go, now I want you to do this. They already think what? They already think you suck, okay? Because you haven't made any change for them, you spent time with you. Now you want them to do something even more drastic. They're not going to be motivated to do it, right? Whereas in the beginning, you go, listen, I want to have a very aggressive approach with you. Let's just go at it. Let's have some severe dietary restrictions. Let's just hit you with a whole bunch of supplements that hit these pathways very aggressively, and let's just see what we can get out of you in the next 6 weeks. Do you want to do that? Most patients want to do that. Most patients are tired, and they're willing to just be aggressive, right? They don't want to dibble-dabble anymore. They want to take it to the next level, okay? So that's where the basic program comes in. Now, for those that have more of a severe inflammatory autoimmune type of response, we go ahead and we add in a couple other things to it, which is the nitric balance and the glutathione recycler to help modulate the INOS, TH17, TH3 regulatory system better, okay? So those are the 2 programs we have, and here's the really important concept. Everything in the Repair and Clear program is TH1, TH2 neutral, okay? Every leaky gut product I've seen in the market today is it either has TH1 or TH2 stimulators. Every hepatic liver drink I've seen has either TH1 or TH2. For the wrong autoimmune patient, it could be devastating. Does that make sense? So we want to be very careful and be very neutral. We want to dampen these things, but we don't want to trigger the responses. So that's the Repair and Clear program. The little booklet comes with diets. Weeks 2 and 3, they're on the leaky gut diet. Weeks 4, 5, and 6, they're on the hepatic type of support pathway. Does that make sense? Okay. So you guys, that protocol is the only way I can share with you as a clinician to dampen that NF-kappa beta chronic amplified loop. Okay? You can't dibble-dabble with that. You have to go aggressive. You got to get the patient on board. You got them to commit to some restrictions for a while, and you want to see how that thing responds. How long they stay on it depends on how they feel. Some patients will just know if they do some of the suggestions, they will feel better. As soon as they start deviating away from them, they feel worse, and they can then use that as a guide to what they use, how long they use it. They may not feel like they need everything over time, but there's certain key things they take that really makes a big difference for them, and those are the things that can be useful for them. Now, next time we meet, we're going to do the most common autoimmune responses, signs and symptoms. We'll talk about loss of self-tolerance. We'll add to this picture because we got to become experts in autoimmunity and chronic inflammation and things like that. Thank you guys for coming, and I'll stick around if you have any questions. Thank you.